Hello. In this video, we're going to continue our introduction to the real Taylor or RT curve. We're going to be incorporating into this video a spreadsheet-based exercise that you will have access to, and hopefully this spreadsheet-based exercise will give you a little bit more understanding as to why the RT curve is shaped the way it is shaped. Now, in the previous video, we learned that the real Taylor or RT curve slopes upwards if the zero lower bound is not constrained. Well, this reflects the objectives of the central bank when it is free to raise or lower the interest rate. It needs to keep inflation close to the target. It also needs to keep output close to potential. So, in conjunction both with its direct objective to keep output close to potential and indirectly to keep inflation close to the target, the central bank will need to raise real interest rates when the output gap rises. However, if the zero lower bound constrains, the central bank is not free to reduce interest rates if the output gap falls. Why? Because interest rates in nominal terms are as low as they can go. That means that the RT curve is going to slope downward if the zero lower bound constrains. Why? Because if the output gap falls, inflation falls, and if the central bank is not free to reduce nominal interest rates, then the real interest rate has to rise. Recall once again that the real interest rate is approximately equal to the nominal interest rate minus inflation. So, we're going to be moving to our spreadsheet. There's going to be 4 steps. In the first step, we're going to use a Phillips curve to compute the inflation rate. In the second step, we're going to use a Taylor rule to compute the nominal interest rate that the central bank will set, and we're also going to look for the zero lower bound. In the third step, we're going to compute the real interest rates. That's the real Taylor curve. And in our fourth step, finally, we're going to examine the slopes of the curves. So here we have our spreadsheet, and as you remember, the first step is that we're going to be computing the inflation rate using the Phillips curve, and we've put the Phillips curve in here as a kind of a little cheat sheet. So you'll notice that over in this column we have the natural rate of interest, which is constant. We're not going to be using that yet. In the next column we have the expected rate of inflation, which is 2.4%, so we'll be using that. In the third column we have the target rate of inflation, which is also 2.4, so we say that the central bank is fully credible in this case, but we're not going to be using that just yet. Now here we have a range of output gaps, from a high output gap of 3%, and we go down, 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 to a very low output gap, a negative output gap, a severe economic downturn of minus 8%. And in this column we have shocks to the short-run aggregate supply curve, what we call production-based shocks, PBS, but we're going to keep these guys constant. Okay? So now it's very fortunate that we have our cheat sheet here. I must mention also that we have a key parameter here. This is the elasticity of aggregate supply in the short run with respect to the price level, and we're just going to assume that's equal to 1. So let's apply our Phillips curve, something that we learned in previous chapters. So the inflation rate, first of all, has to be equal to the expected inflation rate, plus we're going to do 1 over the short-run elasticity of supply, and we're just going to nail that guy in using our little trick, and then we're going to open up a set of parens, and it's going to be the gap minus production-based shocks, which are always going to be 0. So now we see that in our first example, when the gap is relatively high, 3%, we can see that the inflation rate is far above the expected inflation rate. It's at 5.4%. But now what we're going to do is we're going to copy this down here, and we can do that because we have nailed down the elasticity here, And what do we find? We find that as the gap goes down, the inflation rate also goes down, and in this highly negative gap, we actually have a negative inflation rate. We have a deflation, okay? Let's go to step 2. Step 2, we are going to compute our nominal rate of interest according to the Taylor rule. So fortunately, again, we have our cheat sheet here. You've looked at this before, but let's implement this equation. First of all, we're going to put in the natural rate of interest, which we learned in a previous chapter, plus we're going to put in the expected rate of inflation, plus now we're going to put in the response to inflation relative to the target. So we start off here with this parameter here, beta, and we're going to nail that down, and then we're going to put the inflation rate, which we just calculated from the Phillips curve, minus the target rate of inflation. So you can see that in this case, the target rate of inflation is below the actual rate of inflation. But we're not done yet, because we also have to put in the response to the output gap. So we're going to put in here this coefficient, and we're going to nail it down, and then we're going to take this multiply times, and we don't need a paren there. We're going to put the output gap, which we've already assumed in this case here, to be 3. Now the last element here is the discretionary element, but we're going to ignore discretionary elements in this example. So instead, we should have a Taylor rule interest rate of 11.2. So now let's just make sure that we've nailed down the coefficients, and what we can do now is we can copy this in, and you'll see that as the gap goes down and the inflation rate goes down, the Taylor rule interest rate, the interest rate that is prescribed by the Taylor rule for the central bank to follow, goes down and down and down. You can see that between this higher level, 11.2, and this lower level, 1.2, the zero lower bound doesn't constrain, because the Taylor rule is telling us that our interest rate should be above 0. But you'll also notice here that once we get below that value, the Taylor rule tells us that the zero lower bound constrains, that we can't go below 0. There's a fancier way to do this, but what we're going to do here is we're just going to wipe that out. We're going to put 0, 0, 0, 0, and 0. Okay? These are the values, once again, for which the zero lower bound constrains. Now we're going to compute the real Taylor rule. And what is the real Taylor rule? It's just the real interest rate, which is the nominal interest rate minus the inflation rate. Okay? And you will see here for example, up top here, our nominal interest rate is 11.2, our inflation rate is 5.4, so our real interest rate is going to be 5.8. As we can see, the real interest rate goes down, 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 and it keeps going down. But now notice this. Now that we're in zero lower bound territory, as the inflation rate continues to fall and it gets more negative, the real interest rate begins to rise. So now let's take a look and see how we've graphed this here. So the orange line is the nominal interest rate. That's right here in this column, and you can see that over this range, as the output gap goes up, the nominal interest rate also goes up. But right here, where I have my cursor, is where the zero lower bound kicks in, and you can see that here the nominal interest rate is 0. It just can't get any lower. Now let's click on this line here, and you can see that this is our line for the real interest rate, the nominal interest rate minus the inflation rate. So long as the zero lower bound does not constrain, we have a positive relationship between the output gap and the real interest rate. But right here, as the zero lower bound constrains, we get into this topsy-turvy dynamic that since as the output gap falls, the inflation rate falls, the nominal interest rate stays where it is, which pushes up the real interest rate. So this is our zero lower bound territory.